The next rule we'll cover in section 3.3 is the quotient rule. Now, if we have both functions f and g which are differentiable, and y is the quotient of f and g, then the derivative is as follows. It's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So if we take a look at our first example, we are given two functions that are being divided. So to find the derivative, it's going to be the denominator times the derivative of the numerator, which is going to be 2x plus 2, minus the numerator, which is x squared plus 2x minus 3, times the derivative of the denominator all over the denominator squared. So again, you're done calculus right there. Now it's just a matter of simplifying. So if I multiply out my two binomials, I'm going to get 2x to the fourth plus 2x cubed plus 2x plus 2. I'll distribute the 3x squared and the negative sign to get minus 3x to the fourth minus 6x cubed plus 9x squared. And this is all over x cubed plus 1 squared. And usually we don't FOIL out the denominator, we just leave it as is. So now we collect like terms. 2 and negative 3 is going to be negative x to the fourth. 2x squared cubed, take away 6x cubed is negative 4x cubed. And I have a plus 9x squared plus 2x plus 2 all over x cubed plus 1 all squared. And there would be your final answer in simplified form. This next example, this one here is probably one of the most challenging ones you'll see right now. And just like when we did product, you want to get rid of any radicals. And now I'm going to take the derivative. Now, it's not the derivative that makes it challenging, it's the simplifying. So the derivative, again, is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the denominator squared. So again, you're done calculus right there, and you'd get 3 marks out of 5 if this was an assessment that we were being evaluated on. Now, to simplify this, I'm going to move this x to the minus 1/2 down to the denominator with the 2 become x to the positive 1/2. So now I'm really multiplying this by 1 plus 2x over 1. So that's going to give me 1 plus 2x over 2x to the 1/2 minus 2x to the 1/2 all over 1 plus 2x all squared. Now, there's a couple of ways we could evaluate this. Okay, the easiest way we could do is we could get a common denominator in the numerator, combine my numerators, and then multiply by the reciprocal of the denominator, and that would give us our simplified answer. But there's kind of another way we could do it. What we're going to do is we want to get rid of our fraction in the numerator, so I'm going to multiply each term by 2x to the 1/2. And you have to make sure you multiply the term in the denominator by 2x to the 1/2 as well. So in this first term, these two guys are going to cancel out. So I'm going to be left with just 1 plus 2x, which is the numerator here, minus, when I multiply these two together, I get 2 times 2 is 4, and x to the 1/2 times x to the 1/2 is going to be minus 4x. And this is all over 2x to the 1/2 times 1 plus 2x all squared. And now when I simplify, I'm going to get 1 minus 2x all over 2x to the 1/2 and 1 plus 2x all squared. And that would be your final answer. So technically speaking, what we did here is just like getting a common denominator in the numerator and multiplying by the reciprocal of the denominator. But if you multiply through to get rid of any fraction in the numerator, provided you multiply each term, it'll work out to be the same thing. Okay, in this next question, we're asked to find the equation of the line tangent to the graph of f at the point 0, 1/2. So again, to find the equation of a tangent line, you need slope and point. So I already have my point. And to find the slope, I have to use the derivative. So this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So now they want us to evaluate this when the x-coordinate is 0, so I can plug 0 in right away. So I get 3 times 0 plus 2 times 2 times 0 minus 1 minus 0 squared minus 0 plus 1 times 3 all over 3 times 0 plus 2 all squared. So again, times it by 0, we know it's going to be 0, so this will cancel out, this will cancel out, this will be gone, and this will be gone, so I'm left with 2 times negative 1, which is going to be negative 2, and negative 1 times 3 is going to be negative 3, all over 2 squared, which is going to be 4. So my slope is going to be negative 5 over 4. So now to find the equation, y minus y1 is mx minus x1. Again, my point was 0 and 1/2, so it's going to be y minus 1/2 is going to be my slope, which is negative 5 over 4, x subtract 0. And if I distribute the negative 5 over 4, I get negative 5 over 4x times 0 is 0, and I'll add the 1/2 over. And my final answer should be y equals negative 5 over 4x plus 1/2. Okay, another multiple choice question from an AP exam question, and it says, what is the instantaneous rate change at x equals 2 of the function given by f of x equals x squared minus 2 over x minus 1? Again, they're just testing your knowledge that you know instantaneous rate change means the derivative. So this is basically just asking us to find the derivative and evaluate it when x is at 2. So again, I need to use the quotient rule. So f prime of 2 is going to be 2 minus 1 times 2 times 2 minus 2 squared minus 2 times 1 all over 2 minus 1 squared. And this works out quite nicely because the bottom just works out to be 1, so I don't need to worry about it. This is going to be 1 times 4, which is going to be 4, minus, this is 4 minus 2, which is 2. So my final answer should be 2, and my answer would be D. Okay, the last example, we are given the following function. Again, this is another AP exam question, and we're asked to find the derivative. So again, f prime of x, I'll have to use the quotient rule. So it's going to be x cubed bottom times the derivative of the top minus the top times the derivative of the bottom all over the denominator squared. And if you notice, that is not one of the solutions, so I need to simplify further. Distributing the negative 1, I get negative x cubed minus 2. Distributing the 3x squared in the negative, I get negative 15x squared plus 3x cubed, and this is all over x cubed plus 2 all squared. And collecting like terms, I'm going to get 2x cubed minus 15x squared minus 2 all over x cubed plus 2 all squared. So my final answer appears to be question C. Notice in these two examples, this question number 10 had 5 answers. This one now has only 4. And the newer exams now are down to just 4 multiple choice answers. So the chance of even guessing correctly is increased because you have less responses to choose from. Okay, our last example is from the 2016 free response portion of the exam. And it says we're given functions f and g. They're continuous and have second derivatives. The table gives values of the function and the derivatives at second selected values. And in part B, we'll just look at part B right now. We are asked to, we're told that h of x is the product of g over f, and we're asked to find h prime of 1. So h prime of x is going to be the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom all squared. And now we're asked to evaluate this at 1. So this is going to be f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 all squared. So now I don't have a function to deal with, but I can read these values off my table. So therefore, h prime of 1 is going to equal f of 1. So f of 1 is equal to negative 6 times g prime of 1, and g prime of 1 is equal to 8, minus g of 1 is equal to 2 times f prime of 1 is equal to 3. This is all over f of 1 squared, and f of 1, again, is negative 6 all squared. So this is negative 48 minus 6 over positive 36. This is going to be negative 54 over positive 36. And you could reduce this. 9 goes into, that's going to be what, negative 6 over 4, which reduces to negative 3 over 2. And that would be your final answer. So again, in AP Calc, it's a free response question. Believe it or not, they would allow you to finish right here. But again, this question wasn't too hard to evaluate to get an answer of negative 3 over 2. Okay, that ends the section on the quotient rule. Again, there'll be a handout in class that you can refer to and a few questions from your textbook, so give those a try and see how you do.